Okay, so good morning. Today we are going to just do a quick review on section 7.4 and 7.5, which involved the infinite geometric series. It also had in it the recursive rules, and that is what our quiz will be on. So that's what we're going to review. Okay, so for the first thing that we want to go over here is, and I'm going to write this up at the top, but your equation for the sum of an infinite geometric series, get this, is the sum will equal a sub 1 over 1 minus r. Now we have to remember something though, that the absolute value of r needs to be less than 1 in order for this formula to be something that you can actually use. If that r value is greater than 1, then you just have to say no sum. And make sure you remember that because that is something that you don't want to get wrong. Okay, so back from the original rule, we know that a sub n equals a sub 1 times r to the n minus 1. So that can easily help us identify that information here. So here our a sub 1 is 8, but the r value is 1/5. Now, the absolute value of 1/5 is less than 1, so we know we can use this sum formula. So therefore, we can go ahead and find the sum. So we take the a sub 1, which is 8. We put it over the 1 minus the 1/5. So now we have 8 divided by 4/5. And 8 divided by 4/5 is really like 8 times 5 over 4. And we end up with 10. So the sum here is approaching 10. So you'll notice it says find the sum of the infinite geometric series. Technically, it's not actually going to equal 10, but it will approach 10. So it would get to like 9.9999 as you got as the number for n increased. All right, let's take a look at number 2. So again, here my a sub 1 is 2. My r value is negative 1/6, and if I do the absolute value of that, it is still going to be less than 1, because absolute value of 1/6 is just 1/6, which is still less than 1. So we can find the sum here, or what it's approaching. So our a sub 1 is 2, and that will be 1 minus negative 1/6. Now remember, when you subtract a negative, you're really adding. So that's 7/6. So 2 divided by 7/6 is really like 2 times 6 over 7. And then that means our sum will be approaching 12/7. And then the third infinite geometric series problem here. So this time we know that a sub 1 is 2/3, but we have to find our common ratio because it's not in the rule format. So if we kind of look to see, okay, what's being multiplied each time to get from one to the next to the next. So it looks to me like we're going to be multiplying it by negative 1/3 to get to the next number. And the absolute value of negative 1/3 is positive 1/3, which is still less than negative 1. So we can use the sum formula. So 2/3 divided by 1 minus negative 1/3. So we have 2/3 divided by, that's going to change to a plus, so that'll end up being 4/3. And 2/3 divided by 4/3 is really multiplied by 3 over 4. And that would give us a sum approaching 1/2. Now, all three of those examples did work, but I can almost guarantee you that on the quiz you will get one where it is no sum. So just make sure you're checking that r value carefully to make sure that you actually can calculate the sum. Okay, so then we did use this formula to help us find or convert a fraction or a decimal, into a fraction in lowest terms. So basically, you have to remember what is repeating. So in this case, just that 9 is repeating. So our a sub 1 is going to be 0.9. And since there's only one digit repeating, our r value is going to be 0.1. And then we're just going to plug it into that formula. So 0.9 over 1 minus 0.1. And that's going to give us 0.9 over 0.9. And interestingly enough, this one is actually just going to round up to 1. So that's a perfect example of where the sum doesn't actually equal that number. It just is showing you what it's approaching, because we know that 0.9999 repeating is not exactly 1, but that would be the sum that's approaching. And then for number 5, we have a number in front of the decimal. We're not going to worry about that till the end. Our a sub 1 then is going to be the 0.32 that's repeating. Since there's 2 digits repeating, the r value will be 0.01, and then we will use that infinite geometric series formula. So 0.32 over 1 minus 0.01. So we're going to get 0.32 over 0.99, which is 32 over 99. And of course, we have to put that number that was out front of the decimal there. So that would be our answer, 32 and 32/99. And I do not believe 32 over 99 reduces any further. If it did, you would want to simplify it. Okay, so for number 6 and 7, we're now going into using the recursive rules, and it wants the first 5 terms. So if we're doing the first 5 terms, your final answer is going to be something like this sequence. Now we already know the first term is 1 because that one was given to us. So now if I want to find the second term, I'm going to have to take my a sub n minus 1, which just means it's 1 before it. So if I'm finding my second term, my a sub 2, then that's going to be a sub 1 plus 3. Now we know a sub 1 is 1 because we just did that, and 1 plus 3 equals 4. So that would be the second term in the sequence. So now I need to find my third term in the sequence, or a sub 3. So my formula tells me that I'm going to take the a sub n minus 1, so 3 minus 1 would be 2. So the term that's 1 before it is a sub 2, and I'm going to add 3 to that. Well, the answer I got in a sub 2 is 4, and 4 plus 3 is 7. So you can see that we're basically just taking the answer from the previous one, or the previous number in the sequence, and we're adding 3. So to find a sub 4, I'm simply going to do 7 plus 3, which is 10. And to find a sub 5, I'm going to do 10 plus 3, which is 13. All right, now the next one, they're giving us 2 numbers to start with. They're giving us the a sub 1 and the a sub 2. And then the formula is that we're going to be multiplying the answer from 1 before it, or the number, the term in the sequence that's 1 before the number we're trying to find. And we're going to multiply that by the one that's 2 before it. So we already have 2 and 3, and we need the next 3. So if I'm going to find the third term in the sequence, which is a sub n, I'm going to do the a sub 2 times the a sub 1. In this case, I know a sub 2 is 3. I know a sub 1 is 2. And when I multiply those together, I get 6. So basically 2 times 3 was 6. So to find the next term, a sub 4, I'm going to do the one before it, which is a sub 3, times the one that's 2 before it, which is a sub 2. So I'm basically going to be multiplying 6 times 3, which is 18. And then if I were to find my last one, because remember this is a sub 1, this is a sub 2, a sub 3, a sub 4. To find a sub 5, I'm going to take the 18, which is my a sub 4. I'm going to multiply it to the 6, which is my a sub 3. And I am going to get 108. So that would be the first 5 terms of the sequence would be these 5 right here. All right. Okay, so moving along. So now this was the more challenging part of these couple sections here. It said find the next 2 numbers in the sequence. There's a couple things we have to do here. Find the next 2 numbers in the sequence, identify them as arithmetic, geometric, or neither, and then you have to write a recursive rule. So that is a little bit tricky. Some people try to do the explicit rules, but we're just going to do the recursive rule. So if we were doing the recursive rules here, let me write those formulas down for you. So if you're going to do, let's say, geometric. Okay, now recursive rules, you need to provide that a sub 1 and then you would have like a sub n equals r times a sub n minus 1. So that's what you would be doing for geometric. Okay, for arithmetic, again, you need that a sub 1, whatever that is. And then you're going to have a sub n equals, or sorry, a sub n minus 1. That's right, a sub n minus 1 plus d. Okay, so first thing, let's look at these. Okay, so the first one here, first thing you want to do is find the next two numbers in the sequence. So while you're finding those next two numbers, then you can kind of identify it as arithmetic, geometric, or neither. So to get from 4 to negative 12, I'm going to multiply by negative 3. To get from negative 12 to 36, I would multiply by negative 3, and so on. So I can see here that my r value is negative 3. My a sub 1 is the 4, and this is definitely geometric. Now the next two numbers, 324 times negative 3 would give me negative 972. And multiply that by negative 3, I would get 2,900. Sorry, it's a little 16. Okay. So now that I have my geometric, I've done this part of the instructions, I found the next two numbers, I now need to write the recursive rule. So I know my a sub 1 is just that first number there, the 4. And then all you have to plug in for this rule, just look in your formulas, write the r, which we know is negative 3, times a sub n minus 1. That's it. Just make sure you're using the recursive rules and not the explicit rule formulas. Okay, so for the next one, 1 to 8 to 15 to 22, it looks like I'm adding 7 each time here. So that would make this one arithmetic because I'm adding 7 each time. So that D is 7, and of course my a sub 1, I'll write it down here, is 1. Now again, don't forget we have to still identify the next two numbers in the pattern. So 29 plus 7 would be 36, and 36 plus 7 would be 43. So I've identified the next two numbers in the sequence. It is an arithmetic sequence. I have my common difference and my a sub 1, so now I can use my recursive rule. Make sure you give me that a sub 1. It's not complete without that. And then a sub n equals a sub n minus 1 plus 7. Okay, so now the third one's going to be a little bit trickier because if you look at this pattern, you can see that it's definitely not adding the same thing each time, and it's also not multiplying. So it's neither geometric or arithmetic. So that's going to be a little bit trickier. Luckily, the quiz will be multiple choice, so you'll have a few options to try out and test. So now what is the formula? So typically, especially since we're using recursive rules here, if it's not geometric or arithmetic, I'm going to figure that it's something happening with the previous terms to get the next term. So like, how could I get a 7 from this 4 or from the 4 and the 3 or whatever? So I know 3 and 4 add up to 7. Do 4 and 7 add up to 11? Yes. Do 7 and 11 add up to 18? Yes. So it looks to me like to get a number, any term in this sequence, so let's say I want this one here, I would have to take the previous two and add them together. So for any a sub n, I need to take a sub n minus 1 and add it to a sub n minus 2. And you would also need to include that a sub 1, which is 1, and the a sub 2 here, which is 3. So you would need all of this to make that a complete recursive rule. If you use an n minus 1, you need to have a sub 1. If you use an n minus 2, you need to have an a sub 2 given to you so that you would be able to start with something to use that rule to create a sequence. Okay, and then finally, let's go over the iterations. This is just when we're basically plugging in and working off of that number that they're giving us and then the answer and so forth. So we're going to find 3 iterates. So the first one we're plugging in here is going to be that 2. So for the first one, we're going to do 1/2 times 2 minus 3. That's going to be 1 minus 3, which is negative 2. So for the second iterate, we're going to plug in the -2. That's going to be -1 minus 3, which is -4. And then for the third one, we're plugging in the -4. -2 minus 3 is -5. And those would be my first 3 iterates for that example. Now for number 12, we're going to start with the -2 and we're going to plug that in for x. So we have 5 times -2 plus 6, -10 plus 6, which would be -4. Then we're going to plug the -4 in for x. So 5 times -4, which is -20 plus 6, so -14. And then one more iteration, we're going to plug the -14 in for x. We multiply that by 5 and then add the 6 and we get -64. So those would be our 3 iterates for that one. All right, and then finally we have this word problem here. A pendulum is released to swing freely. It travels 30 inches on the first swing. So when something's telling you what's happening on the first swing, that's basically a fancy way to tell you what the A sub 1 is. On each successive swing, the pendulum travels 75% as far as the previous swing. So your R then is 0.75, or that's 75%. Now, you're just using, what is the total distance? So you're using that sum formula for the infinite geometric series, because a pendulum is something that swings. Like, you ever see those little metal balls on one of those, like, I don't know, they take the last one, they lift it up and they like let it go, and then it bangs into the next one, and then that goes. That's sort of like a pendulum, right? So if you started that, technically, it could, as it goes, they're going to get smaller and smaller and smaller, those little movements. So, eventually it'll stop at some point, but we're just going to find the sum of the total distance, and we just know that it's going to go 75% each time of the previous swing. So we're just going to plug that information to that infinite geometric series formula. The A sub 1 is 30. That's the distance of the first swing. 1 minus the 0.75, which gives us 0.25. And then when you work that out on your calculator, you get 120, and we are dealing with inches here. So it'd be a 120 inches. And that's basically it for today's review. Just check in with me if you have any questions. And that's pretty much it. Hope you guys have a great rest of your day.